things that have carbonated skeletons, coral reefs, plankton. And actually the whole ecosystems that these things build and that other organisms that are associated with. Implications for industries, tourism, fisheries, and so on. Many of these things we are only now learning about their consequences. A lot of unknowns in the actual effect on ecosystems. There's I can say there's 100% certainty of what's happening here because the physics and chemistry of the dissolving seawater, of CO2 in the seawater, is very, very well known. There's no problem about that. It's just what the effects are on the marine ecosystems. Just to show you more evidence, anyone ever doubted that CO2 was penetrating into the oceans, from our coral record, we now able to show that over timescales of several hundred years, there's been a marked change in the isotopic composition of carbon we see in our corals, which reflects the surface waters. And this change downwards is called the Zeus effect because it's actually being pulled down by the burning of fossil fuel carbon. So fossil fuel carbon lies down here, and it's pulling this whole curve down in exactly the way you'd expect as we're putting more CO2 into the atmosphere. So it definitely is a real effect. Okay, sea level, very briefly talk about this. This paper is showing data from various sources, including satellites over the last 100 years or so. Actually, the blue line is the data. And what someone did, and you notice there's been if you look at the data, it actually decreased, the rate of increase slows down somewhat. And this has been a little bit perplexing for a while. And then this author, said, well, what happened, what if we account for the amount of water being put into dams? A lot of dam building started in the 1960s. And if we account for the water stored on that land from damming, it shifts it from the blue to the red curve. The other interesting thing is, of course, that the last 30 years or so, the rate of increase is almost, this curve actually looks like it's starting to increase again in its rate. Now, with sea level rise, there's two basic issues to be concerned about. First is the thermal expansion due to oceans warming, which we've discussed, and the other is large-scale melting of the ice sheets, where most of the ice is stored, for example, the Antarctic ice sheet, and also to a lesser extent in Greenland. Actually, in WA, we have some of the best evidence that there's been large-scale melting of ice sheets in the past. In this last interglacial event I showed you earlier, this is 120,000 years ago, down at Margaret River, or the beach at Margaret River, not actually Margaret River itself, you can find coral reefs that are plus 3 metres above sea level, and we know that at ocean temperatures are about 2 degrees warmer. So the simple thing, if we have oceans a couple of degrees warmer, it's very easy to get sea level rises of plus 3 to 4 metres. We know it happened in the past. You can stand, this is someone standing on top of this coral reef. The only thing is not likely to, I should say, unlikely to grow coral reefs down this region in the next few hundred years because we have this offsetting problem now of ocean acidification, where the CO2 is going to stop the calcification rate. But nevertheless, the oceans are going to warm. What about in Perth itself with what's happening with sea level there? We actually have very good tide gauge records, for example, from Fremantle, and this shows that the sea level at Fremantle has increased by about 20 centimetres in the last 100 years, a real effect. This is actually a picture of Riverside Drive. Here's a dotted little white line taken in 2003 during this event. And you do see actually the issue of variability is quite important here because the tides aren't smooth. If you get these 20-year cycles, and when the next big cycle comes superimposed upon the ever-increasing sea level, then the walls they're now building along here, if you notice, may even have to be much higher. So this is the kind of issue that's a real issue for all of us. Now to sort of head to the home straight, what do we do in the future? We have some choices to make. We can do nothing, let CO2 continue to rise. And if we do that, then temperatures will rise along this path with the uncertainty shown. For example, if we let CO2 rise to up to 1,000 ppm, we could easily get temperatures that would be 4 to 5 degrees higher, but could be as high as 7 degrees higher. What's the target we should aim for? Well, we should try and get onto this blue curve where we should try and halve our emissions by about 2050. Oops. And if we take this path across here where we try and put a lid on CO2 emissions, then we can start to go on this path here with respect to temperature, i.e. keep our temperatures less than 2 degrees. And actually the choice is ours. It's really a societal choice of what we do with that, or how we use energy and what we're prepared to do to be more efficient energy-wise. So here's the choices. We can do nothing and things go. We can dither and delay, which we're sort of doing now. But we can, somewhere between these points, if we can start to take action, we can certainly hope to put a lid on temperature rise to less than 2 degrees. And if we get very serious and try and reduce CO2 emissions totally back to near zero, so we get back to our natural levels, we can in fact start to decrease temperatures. At the very least, we should try and stabilise it. On that point, I'll